Good day guys, you're welcome to this channel. This is Idowu Maths class. I'll be teaching you mathematics here, especially your grade 9, GSS 3. Please, anytime you are with me, always come with your biro and your book to jot. And in case you don't understand any part clearly at a point, you can always play back. Thank God for technology. So I want to encourage you to pay rapt attention, believe you can understand every concept, and you will. Today, we are going to start from number basis. What do we mean by number basis? Numbers can be in different bases. Number can be in base 2. Number can be in base 3. Number can be in base 4, base 5, base 6, base 7, base 8, base 9, base 10. We can have base 11, 12, and so forth, but for your level, let's stop here. Numbers can be in all these bases, but all these bases, some of them have special name, like this base 2, we call it binary base. This base 8, we call it octa base. And this base 10, we call it denary base. All these three, they have their special names. Others, they don't have special name. Now, from base 2 through to base 9, we call them order bases. Order bases. Please take note of all these different points I'm mentioning. From base 2 to base 9, we refer to them as order bases. While base 10 remains base 10, which is denary in special name. Now, there are 3 levels of conversion in number bases. We can convert a number that is in base 10 to order bases. When we say to order bases, you can now understand that to base 2, or to base 3, or to base 4, or to base 5, to base 6, to base 7, to base 8, to base 9, or to base 11, 12, and so forth. So, conversion of base 10 numbers to order bases can now be clear to you now, because that is where we are starting from. Conversion of base 10 numbers to order bases. So, let's start with example 1. Convert 20 to a binary number. What do we mean by this question? When a number is written ordinarily, without any base put as its subscript, and without any words giving us the information about a particular base the number is, you just take the number as being in base 10. Like you have 20, you have 75. When you have just 75, without any base put at its subscript, then that 75 is in base 10. So 2 ways to recognize base 10 numbers. 10 can be put at its subscript, 20 base 10. Or nothing may be put. When something is put, like this, is in base 10, and that thing is base 10 is 10, then it's in base 10. When nothing is put, take it also as being in base 10. So, I remove it because I like it being without 10 put at its subscript. And when it is put there, there's no crime. Now, convert 20 to a binary number. That is, 20 that is in base 10. Convert it to a binary number. That is, a number that is in base 2 is what we call binary number. To convert any number in base 10 to any other basis, be it base 2 or base 3, 4, 5, 6, 7, 8, 9, 11, 12, any other one, to any other basis, there is only one procedure for converting numbers in base 10 to other bases, and that is long division procedure. This is it. Long division procedure. Look at it. What are we converting it to? Base 2. You use the 2 to divide. If we are converting it to base 3, you will use the 3 to divide. If you are converting it to base 4, you use the 4 to divide. You are converting it to base 5, use the 5 to divide. I want to believe you understand it. Now, 2 divides 20 10 times, and it remains 0. 2 goes in 10 5 times, it remains 0. 2 in 5 is 2, it remains 1. 2 in 2, that's 1, it remains 0. 2 in 1 is not possible, you put 0. You now repeat that figure on which we have the impossibility. Repeat it down here. You say remain that same number. See what it remains. You now put an arrow down here, let it show up. Meaning that you are picking your answer from the bottom. Therefore, 20 base 10 is equivalent to 1, 0, 1, 0, 0. What base? Base 2. I encourage students to always write their base in words in order to avoid mistake like 101002. If you mistakenly write it like this, and you think you have put the 2 at the place of subscript like 10100 base 2. You know, this is clearer than this. This looks as if you write a block of number. So, teacher may decide to, judge you and mark it down. Meanwhile, here, where it is clear, you'll be given. But when you write it in words, even if you make mistake of writing it like this, teacher will quickly understand and consider you. So do you understand? So that is it. Let's consider this example 2. Convert 49 to a binary number. It's just like example 1. 49 is in base 10. We have to convert it to a number in base 2. So that means divide that 49 repeatedly by 2. 2 in 4, that's 2. 2 in 9 is 4, remains 1. 2 in 2 is 1, in 4 is 2, remains 0. 2 in 12, that's 6, remains 0. 2 in 6 is 3, remainder 0. 2 in 3, we have 1, remainder 1. That is, we can have 2 in 3 one time, and it remains 1. 2 in 1 is not possible. We cannot have 2 in 1. So we write impossible. The language of impossibility here is put 0. We now repeat the number that remains here. So we put the arrow here to show that we are picking the answer from the bottom. You understand? From the bottom. So we have 49 base 10. If you put it, it's not a crime. It's equal to 110001 base 2. And that is the answer. Do you understand? Let's consider example 3. Convert 129 to base 3. 129 is a number in base 10. So we are converting it to base 3. Let's engage it in long division. We divide the 129 by the base to which we are converting the number to, base 3. 3 in 12, that's 4. 3 in 9, that's 3. Remainder 0. 3 in 4 gives 1. It remains 1. Use the 1 with 3 forming 13. 3 in 13, that is 4. That one remains 1. 3 again. In 14, that is 4. Remainder 2. 3 in 4 is 1. It remains 1. 3 in 1 is not possible, so we write 0. We repeat this same number 1 here. And we carry our answer from the bottom. Therefore, 129 base 10, if you so wish to write it like that, is equal to 11210 base 3. If you write your 3 in word, good. If you write it in figure, it's okay as well. Let's consider this example 4, which is going to be the last example under this subheading. Example 4. If 89 is equal to x base 5, find x. What does this question mean? What is the interpretation of this? 89 is in base 10. Unknown number is in base 5. And they are equated to each other. What does that mean? It means if 89 base 10 is converted to base 5. That's the meaning. If 89 base 10 is converted to base 5, what's the number? That's the question. So and what do? You try to convert 89 base 10 to base 5. So you write 89 divided by 5. To convert 89 base 10 to base 5, you divide it by 5. You engage it in long division. So 5 in 8 is 1. It remains 3. 5 in 39, because you use the 3 with 9. 5 in 39, that is 7. Why 7? 5 times 7 is 35. And when you subtract 35 from 39, you have 4. So remainder 4. I want to believe you understand. So 5 also in 17, that's 3. 5 times 3 is 15. Subtract that 15 from 17. You have remainder 2. So 5 in 3 is not possible. Because it's not possible, you have 0 to represent it here. Remainder, this same number repeated down here. So you put a arrow up down the bottom of the table, meaning that 89 is equal to 324 base 5. Therefore, x is equal to 324.